Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called merge k sorted lists. We were given an array of k linked lists. Well, each linked list is sorted in ascending order based on their value, I guess. So merge all the linked lists into one sorted linked list and return it. So this problem is categorized as hard, but actually when you understand what is going on, it's not that hard. So let's break it down. So we have an example here. The lists were three different sorted lists with the first one, 1, 2, 5, 1, 4, 5, second one, 1, 3, 4, and the third one, 2, 6. So basically we have to compare the first element of each linked list and put the smallest one in our final list, then go to the next smallest one. In this case, we have another one here, and go to the next smallest one. So if this one goes to the next node, it's 4. And this one goes to the next node, it's 3. And here the next node is 2. So we take the smallest, which is 2, and we put it into the final result and then move to the next node. So next round, we're comparing 4, 3, and 6. So after they were arranged like that, okay, let's see. So first we need to put 3 here, right? And 3 goes to the next node, which is 4. And we compare 4, 4, and 6. And we have either one, right? So let's say we have this 4, put in the final result. And now this one will be null. So we will not add anything from this list ever to the final result. And now we're comparing 4 and 6. Apparently we're choosing 4. So we put 4 here, and then it goes to the next node. And comparing 5 to 6, we have 5 as our next node in the final result. And lastly, we put 6 to the last element of the linked list. Okay, so this is a pretty straightforward stuff, but how do we do this? Okay, let's see. If we have like k lists or k sorted lists, let's say, yeah, we have something like that, right? You get the idea. So we have 1, 2, 3, and 2, 3, 5, 9. Let's do some more. 10, 12, 24. Okay, next we have 6, 10, 23, 76. Okay, so first thing, we need to compare the first element from each list. Okay, and then we go to, after the smallest one was added to the final result, we go to the next node of it and do the comparison again. Okay, so let's say we pop 1 out and we're comparing 2, 3, and 6, and this time we pop 2 out, and 3 we can choose either one, right? So let's say we choose this one, and this one will be null, so we don't have to think about it again. So what data structure could help us achieve this goal? We have k sorted lists, and we want to remove the smallest one. So you're thinking of minHeap, right? If we put all the first element into a heap and we remove the smallest one at each step, we will get our final result. Okay, so let's code it out. To construct the final result, we will need a dummy node as a sentinel to help us construct the final result. Okay, so we have a dummy which is set to a random number, let's say -1, and we will have a pointer pointing to dummy. Okay, now we have our priority queue. Okay, It's going to contain a list node, and we're going to call it heap. So it's basically going to be a new priority queue, but we're rewriting the comparator of this. Okay, so when we compare two stuff together, we will put the smaller one with a higher priority. Okay, so we're gonna write new comparator for list node, and yeah, it's gonna be like this. Overwrite. The function we're going to override is compare. Okay, we have list node 01 and list node 02. We're going to return whether 01's value is less than or equal to 02's value. Okay, if it is, we are going to return -1, which stands for a higher priority, and if not, we will return 1. Okay, so basically this is pretty hard to write, and if you're familiar with Java 8 or later, you can use a lambda function to achieve this. We'll talk about it later, okay? And so for all the list node head of each list, I'm going to put it into our heap, okay? So if it is not null, we're going to heap.offer this L, okay? Now we should have a heap of the size k, okay? And now let's construct our final result. So we're going to use this cur node to connect the new result, and we're going to return dummy.next to point to the head of the new result. Okay, so while heap is not empty, we can connect cur.next to heap.poll, and if the heap.poll means the head here. Okay, let me use something to denote it. Okay, as of now, our heap consists of 1, 3, and 6, while 1 is at the top of the heap. So we're going to pop it out, and the next thing is we're going to move it to the next element if it's not null. Okay, so now we're connecting to 1, so we can say if cur.next is not null, we're going to offer it to our heap. Okay, so now we pop it out and we add 2 to our heap. Okay, so when this is done, we are going to move our pointer to the next. Okay, and lastly, we're going to return dummy.next. Okay, so this should give us everything that is not null. Okay, so when this is null, so we're not going to offer anything to our heap. We'll just leave it there. Okay, and cur equals to cur next ensures that if we're at the very last of our new linked list, we're moving to the null. Okay, so this should give us the right answer. Let's take a look. All right, I think it passes. So the complexity here, we're effectively looping through all nodes in all the linked lists. So it's going to be of O n, and each time we're popping it from our heap. So each time it's going to be log k. We pop it this time. This is O1, right? But when we offer, it's going to be log k. So we do it n times. It's going to be O log k, and the space complexity is going to be max of n or k. So basically, I would say it's going to be, yeah, around k something. Okay, let's submit it. Okay, I think it passes. So here for the lambda expression, new priority queue, we can say AB. We can say maybe A dot value is less than B dot value. Okay. So that should give us the exact answer. Okay. And this is so much shorter than the previous comparator override. All right. Thank you so much for watching. I'll see you in our next video.